Okay, welcome back. And today we're going to program the robot the first time. Um, Now we just want to test if the motors well is actually go if it's actually go forward. That's it. And then let's see. Okay, as you see, we have a program here called car test motor only 2021 January 06. So it's today. Um, let's program it and see if it works first. So we go to tool and then we look for the board. You may not have that many selection, but anyway, search for the Mega board, Mega 2560, and then I have to plug it, and then plug in the wires. Okay, your robot may not move, but mine's because I have already programmed it. So go back to the tool and then look for the COM. Like for mine is COM 10. You may have different COM, and then program it. And then now we go to look at the monitor. So we see something. So that's good. And then now let's see if the robot goes straight. It should kind of go straight. So it's straight. If you put on the floor, it actually go like really straight. Why this is important? Because when you do the testing, you have to be sure the two wheels is actually guided by the encoder behind, so that when it goes straight, it won't. For example, if we don't have the guidance, this wheel may turn faster than this wheel. So when it goes, it may turn like this. So eventually it will turn like far away. I don't know where it goes. So in order to be sure two wheels turn in the same amount, we need the encoder behind. So you need to be sure the robot actually goes straight. So this is a good test to be sure the wires it works. So let's have a quick look of this simple program. This is just a library. We may not need that. For the interrupt pin, we have L1, L2, R1, R2, which is these two group of wires. So black and white. And why we need to say, okay, 22, 3, and 18, 19, they are the interrupt pins of the Mega board. So it's specialized. So yeah, you have to use this pin. For the motor drive, you can pick whatever pin because it's just digital pin. 8, 9, 10, 11, which is these. The pins connect to the motor drive. So these 4 pins is yeah, 8, 9, 10, 11, correct. And then there's some parameter, and there's some other parameters only. And then now we go to setup. So remember, for the Arduino code, we just set up and then loop. So two main things. In here we set up the serial port, and then we set up that 4 pins to be output. What 4 pins is these 4 pins? So we just say, okay, this is just an assignment. So pin 1R is 8. Now what is this pin does is set it to output. So it's actually sending signal to this red color board. So it's output. And interrupt pin, we use input pull up. It may be new to you because usually we just say input. And the good things about input pull up, it means that internally there's a pull up resistor. It means that if you don't connect to anything, the pin will be high. So it just say it is an internal pull. it's a good practice to say internal pull-up, because if it's floating, you don't know what the value of the pin, if there's a broken wire or something, and you may get wrong data back, and then your robot may be crazy because of that input error. And then here is the interrupt setting. And what this interrupt setting is about is a hardware interrupt setting. It means that for this pin, interrupt L1 pin, which is the encoder, which is like it's an encoder pin. If that encoder pin is falling from high to low, then go to this subroutine count L. That's it. So same for count R. This is the way to call the interrupt. If you want to know more about the interrupt, you can go to this link. And what's special about this hardware interrupt? It means, for example, if the robot is like doing something and then suddenly there's a falling edge, in here is the encoder. It's a falling edge. It will go to the subroutine and then do something and then come back and then keep working on the program. And the good thing is that whatever happens to that pin, the falling edge of that pin, it will for sure pick it up. So that's what interrupt is about. For example, there's an emergency button, not emergency button. It's like someone touch the robot, for example, and that signal you want to capture it, then you must use the hardware interrupt, because if the robot like just keep looking, read that data in certain period, and then if I touch it and to do something to it, and that input subroutine does not pick it up, then I miss it. But for this hardware interrupt, it means that if I do something and then trigger the falling edge, it will for sure go to the subroutine and do something. So yeah, so it is hardware interrupt. If you want to know more, you can just go to this link. Anyway, we set up this interrupt and take a look of the count L and count R. So this is the interrupt subroutine, count L or count R. It just say, okay, this falling edge of the L1, and then we look at the L2 and see if it is high. If it is 1 or 0 only, right? This part. So if it's high, and then minus. If it's low, and then plus. And this you don't have to do anything, because I already tested and then put the wires into that. Same for R. So if it move one slit, like this kind, you won't use this kind of slit because the slit is inside, but it comes with the package. So if there's a light go past through this slit, if it move one slit and then go to another slit, there's a falling edge for sure. That's on and off, and then it will trigger this this routine, and then it will add or subtract the value from that encoder value. That's it. Then after that, we go to loop. For the loop, we go into the motor control, and then remember we see something in the monitoring system. So this is just to show from the monitoring system. And for the motor control, and remember you have to put a lot of things into the motor control later. And now I just say, okay, forward straight line. And yeah, maybe I put more time into this program. Forward straight line. So when it okay, for the loop, it called the motion control and then print something and then come back and then motion control again. So it will keep running this motor control, and motor control inside is forward straight line, and then here is the program. It's good to make the program more modular, like function within a function and something. Just function call another function, because if this function work right, you don't want to look at it again. you want us to keep using it. So it's good to say, okay, this work, and then I'll keep using it. And there's a lot of way to do it. It just is a quick way for me to get it done. And you can do different ways too. So for this function, first this is the initial variable. So I just say forward start. If it is 0 and then set up something, set up something, stop the car first, and then set the target value 100, and then the encoder value I reset it to 0, 0 and 0 and 0, and then forward start 1. And why I say forward start 1, because afterward when I come back, the forward start is not 0 anymore, it is 1 because I set it 1. So this is the initial value. I only run one time and it won't come back. So this is the initial value. And then after run this, so set up the encoder, the target value. Now we say, okay, the encoder value. The encoder value means when it move, now it's 0, for example, it's set to 0. And then when I turn, it's 1, and then 2, and then 3, and then 4, and then, yeah. So the encoder value will keep increasing. And then this guy will be from 0, yeah, so from 0 to 1, 2, 3, 4. As soon as it's bigger than the target value, I set it to 100, or the right wheels is bigger than 100, then stop the car. And then forward start it with 0, and then restart the whole thing again. And then if the encode else, and then if this is another loop, and if this value is L is bigger than R, it means that the left side it turned too much. So the encoder value is like higher than the encoder value R. So it is like this now. And then now we call the function turn car left. So I want to turn the car left like this. And then same for another, if the encoder value is R is bigger than L, it means this wheel it turn more than the encoder value L. It means that now I have to turn car right. And that's it. And then else it will go forward. So where this function come from, the turn car L. This is the subroutine of the motor of control motor. So this is the lowest level of control motors. So you don't have to touch this because it's already tested. So if it's like turn car L, it means that let's see. Yeah, so the one of the wheels stop and another wheel turn. So it's yeah. And then turn car on site, it means that one wheel turn forward, one wheel turn backward, like this. And yeah, the on site is important later because when you have like a cross, like a black cross in the middle, you want the robot to turn on site. If you just let the robot to turn here, like just turn, it's not on site. After turning, the robot may not in the same spot, and you may get the wrong input output. And the forward car, it means that yeah, it is the lowest level setting. So that's why for this wiring, please double check if they are okay, because the software is based on this kind of same wiring. And then the stop car means all the pins is supposed to be 0. That's it. So yeah, so have a quick look again. Okay, so it will go forward. And then the encoder value, as you see, it will go higher. Okay, stop. So it will go higher and higher and higher and higher until it reach 100. And then it will reset it again, and then we'll keep going. So that's it. So if your robot does not go forward like this, or the robot does not go forward straight, it means that your wiring has problems. So please double check the wires. So that's all I want to talk about today. Okay, thank you.